GATE 2020 Civil Engineering question number 37 set 1. Question says that a water supply scheme transport 10 MLD 10 million liters per day water through a 450 diameter pipeline for a distance of 2.5 km, and they have given some concentration coefficient and discharge values, and after that they have asked us the correct answer that the chlorine dose concentration in mg per liter they have asked. We will study this question properly. After that we will solve this question. For this question, if you want to learn more things, you can refer to this nptel video lecture. So try to understand these questions. So there is a one water supply schema which suppose this is a pipeline. This is pipeline. In this pipeline, a discharge of q1 that is a 10 mld, right? 10 mld passes daily, right? Water through 450 diameter pipeline. This diameter is suppose d1, right? And distance is 2.5 kilometer, right? So chlorine dose of 3.5 mg per liter is applied at the starting point of the pipeline to attain a certain level of disinfection in the downstream, and it is decided to increase the flow rate of 10 mld to 13 mld, right? So current concentration is 3.5 mg per liter. So I will keep it as a C1, right? 3.5 mg per liter. After that he is saying now discharge is q2. Now discharge is q2. Diameter is also same, so d2 is also same, and concentration is c2, and he is asking that c2. When the discharge increases, we have to increase this concentration in order to get a same level of disinfected water, same level infected water, right? So try to solve this question. Very easy question if you know this Watterson law. What Watterson law says that T1, this T1 is nothing but time of contact, time for which this chlorine is in contact with water. So this T1 into C1 is a C is nothing but concentration of chlorine, right? Concentration of chlorine. So this law says T1 C1 raised to power n equals to T2 C2 raised to power n. Here n is a power or by which this concentration is getting applied. There is a relation, and assume this exponent for concentration is 0.86 for various with various changes in this chlorine or chlorine and all this coefficient or exponent changes. So for in this case this n is given as 0.86, right? So we know that this time is nothing but distance upon velocity, and this velocity is nothing but we know that discharge is equals to area into velocity. So we can write down this velocity as a discharge divided by area. This area will go ahead. So we know that in this case distance is same, that is 2.5 kilometer. You can see here 2.5 kilometer is same, and area, pipeline area is also, this area is also, cross section area is same in both the cases, right? So therefore this distance and area will cut out. What remains is nothing but C1 raised to power n divided by Q1 equals to C2 power n divided by Q2. In order to solve this, what is concentration 1, we have to write down and we have to solve this question. let me see what is our concentration 1. So our concentration 1 is 3.5 mg per liter. Write down 3.5 and n is nothing but 0.86. I hope this is visible. I will try to write down quite a bigger font. Divided by 10, this is discharge 1, into this is C2. Same exponential power will be there as per question, and divided by, now the discharge is 13, increase to 13. After solving this for C2, let's solve this for C2. It will come out to be 13 divided by 10, and power 1 upon 0.86. So after and into this 3.5, right? So writing this 3.5 here, so it will come out to be 4.747 mg per liter. So our answer for this question will be 4.747, that is 4.75, option number C. Thank you.